Oh, I think we might be on. Hello, hello, hello. How is everybody? Please let me know if you can hear me, because hopefully we should be online. My computer's being a little bit slow again, so I'm not 100% sure if anyone can hear me. So yeah, please let me know if you can. I'm just going to try and share my screen now as well. But hello everybody, welcome to our first chemistry drop-in, which is very exciting for me anyway. It's my the process of the drop-in. If you haven't heard me say previously, or if you're not sure, the purpose of the drop-in is for you guys to get to have your personal exam questions answered, or specific areas or topics that you are particularly interested in doing. We can go through just that. So if you were to join us on Snapprise on the website next week, then you might get the opportunity, or you could definitely submit your own questions, and then we can answer those questions, and hopefully you guys would then see get a bit more one-to-one support from a tutor. So can you just let me know if you can see me? I think I've got my chat working now. If everything's okay, then just let me know. Oh, it's just being really slow, but hello, welcome everybody, welcome. Apologies for that it took me a couple of minutes to change over from the previous class, because we had somebody on doing physics, I think. So apologies. Please forgive me for being a couple of minutes late, but we're hopefully all good and working now. Just hoping my internet is working, but I still can't see anything on the chat yet, so I don't know if you guys can see me or not. But good. Thank you so much for telling me. Brilliant. You can hear me, and hopefully you can see me as well. Lovely. Well done, guys. So hello. It's really nice. I can see some of these names again of people who have come back. So it's really nice to see you guys coming back, but also welcome if you haven't been before. This is Snapprise Chemistry. This is GCSE Chemistry. So if you haven't already, please feel free to download the slides. The slides are in the description below. And you can then, it means you can practice the exam questions at a later date. You can do it while we're going along with it. You can save it for revision and do it again. It's there for you to use, and you can then kind of keep up with where we're at. So this, yeah, good. Oh, they are fun. You're right, they are fun. Exactly. So we'll have a look. I can now see your chat, so thank you so much for those of you that have been responding, and hello to everybody. So let's get started. At the end of the session, I will go through again what I did at the end of the session last time, and hopefully show you what the website would look like, and where to go in order to join up with this. But first of all, a little bit about me. So this is a drop-in, so we don't have a lesson as such. We've got exam questions, and this is something that I've been doing with Snapprise with our A-level students, and it's something that we're really excited to do with GCSE students as well, because it's a really good chance for people to ask their own questions, get a bit of interactive or interaction with a tutor. So like I say, I've been doing this with in A-level, but I'm also now doing this in chemistry at GCSE, sorry. I'm the lead GCSE chemistry teacher here at Snapprise. I have got a PGCE in chemistry, and I've been teaching A-level chemistry and GCSE science for the last 6 years. So just so that you are aware, we are starting our GCSE tutoring on the website next week. So it's no longer going to be on YouTube, unfortunately, at least not these regular classes. But if you're interested, then please head on over there. We are going to have at least 3 classes a week. So physics, maths, chemistry, and what have I not said? Biology. We'll all be over there. There'll be more than 1 class a week. There'll be drop-ins in all of those as well every week. So loads and loads of classes for you to get involved with. We're going to cover the full curriculum. There are high quality handouts like these ones available every week. There'll be a library of past recordings, so we record everything and then we put it up on the website so you can rewatch things if you need, just to double check revision, or if you miss a session or whatever, you can watch them back. And there's also some one-to-one support on the website as well. So it's really good and a really great revision tool for you guys. So and a reminder, sorry, if you are interested and want to try it for free, which is a great opportunity to just get 2 weeks for free, see if you like it, see if it's the kind of thing you might be interested in doing on a more permanent basis, then please use our tutor code tutor14. That means that you will get a 2 week free trial, and that is from whenever you activate it. So then you get a 2 week free trial of the website, and there's a couple of instructions there on how to activate this free trial, but basically you enter that code at checkout and then it will give you a 2 week free trial. And I'll hopefully show you the website at the end of this session. Good question. Which exam board do you teach? We actually do all three: AQA, Edexcel, and which one haven't I said? OCR. So we will cover specifications for all three. And if there's anything that's particularly different between them, or something that you don't cover in one of the exam boards but you do in the others, then I will say, so that you guys know, whichever exam board you're on, oh, I can ignore that bit, or oh, I definitely need to learn this bit, or whatever. So we will try and let you know what's relevant to your exam board. But if we don't say, then it must be relevant to all three, because there's a lot of overlap between the exam boards. I hope that answers your question. Hello, and hello. Welcome. Let's, I think, get started then. So like I have said, these sessions are there for you guys to ask questions. You can, if you join us at Snap Provides, then you can send questions in advance and we will put them into our drop-ins so that you know that, on Thursday next week, we're going to be covering that question for you, or that topic for you. And then you can come along to the session and ask questions. You can just drop into all of the drop-ins and just see what questions they are. It's a really good revision tool, actually, because it's spaced learning. We cover all sorts of different topics every week, and we grab all the topics from all over the GCSE. It's a really good way to test your knowledge, spot test your knowledge. If you haven't requested a topic, you can just turn up and be like, oh, good, a question on that. I haven't done that in ages. So then we'll have a go. And it reminds you, if you realise you're not very good at it, then maybe you could go and do a bit of revision on it, come back, etc. So really great revision tool. So, hello, Mr. Dan, we are just about to start, or we are started. So, anybody got any ideas? These lessons aren't going to carry on YouTube after the end of this week, unfortunately. They're going to go onto the website. But if you're interested, then please use our free trial, get 2 weeks of free lessons on the website, and see if it's for you, see if you might enjoy it. Good, guys. Very nice, well done. Cool. So we have to talk a lot about the atmosphere. This is actually a 6-mark question, so there's a lot to talk about. So let's just have a look at what you guys have said. What I'm going to do is just to keep it on this page rather than writing it out in full. I know I've got a lovely page to write on here, but I'm actually just going to annotate this slide, because then we can talk about it and we can chat about it as we go along. So the question says, describe and explain how the atmosphere of early Earth has changed to the atmosphere that we know today. So didn't mean to do that. We want to know how the atmosphere of the early Earth has changed to the atmosphere that we know today. So how? It's told us to describe and explain how. So first of all, we can look about perhaps, yeah, nice guys. We're going to look perhaps at what has happened. What has happened between early Earth, which they've given us a picture of, and the Earth today. Now, the early Earth says most of the surface is covered by volcanoes. The Earth today, most of the surface is covered by oceans. And then the early Earth, most of the atmosphere was carbon dioxide and water vapor. And most of the atmosphere in the Earth today is nitrogen and oxygen. So we need to, it's a 6-mark question, so you're going to need to be writing in full sentences if possible. You're going to need to be describing and explaining. So there's effectively two parts to this question. We need to describe and explain how the atmosphere has changed. And they've given us some information already, which is great. So lovely. What topics are these exam questions based on? So this is atmosphere chemistry, which is I thought I had the thing, but I don't. I think it's AQA. It's from the AQA syllabus, this specific question, but I believe it's covered in all of them. I think it might be higher in OCR and EdXL, I believe. I could be wrong though. Yes, definitely paper 2 though. Yeah, well done, Evan. Great. Okay, so what can we talk about? I've seen somebody talking about a water vapor decrease. That's good. A CO2 decrease, oxygen increase. Good. So exactly, I really like what Evan's done. I think it was Evan has done there. Is we've talked about this information that's been given to us, and we're comparing it to the information that was given to us about the Earth today. So we can talk about, well, these are the things we need to talk about. The oxygen increase, how and why is the oxygen increased? We need to talk about the carbon dioxide decrease. What else do we need to talk about? The water vapor decrease. Oops, I need to move my video out of the way. Water vapor decrease. And we can talk about the nitrogen increase as well. Okay, so talk to me then, guys. Why has, let's specifically start off, just because I've done it in this order, doesn't, for no other reason apart from that, let's talk about the oxygen increase. Why has the oxygen in our atmosphere today increased from before? What's caused the oxygen increase? Oh, brilliant. Well done, guys. This is great. Yeah, brilliant, and really good words there. Really good that we're using the word photosynthesis. That's amazing. If you get that in there, your examiner is going to spot that word photosynthesis, but this person knows what they're talking about. Really good. So our oxygen's increased because plants and algae started photosynthesizing, producing more oxygen. And then on the similar vein, which I think some of you have said, yeah, good, well done, guys. Yeah, photosynthesizing in the ocean as well, so our algae in the ocean, really good. Same sort of thing, so we could have done it in one sentence, but I've kind of split it up into 4 different things. Our carbon dioxide decrease is come from the same thing, hasn't it? Plants and algae using carbon dioxide for photosynthesis. So carbon dioxide increased, oops, I should put increased, decreased, because plants and algae used carbon dioxide for photosynthesis. Once life was formed on the planet, we were then able to, or life itself was able to use the carbon dioxide to produce oxygen, and hence a lot of carbon dioxide in the atmosphere has been taken out of the atmosphere and is now being replaced with oxygen. Why else has carbon dioxide decreased? I left myself quite a lot of space for carbon dioxide because there's another reason. What's happened? Oh, I think someone has said it actually. I think the boss has said it. Nice. Oh, I can't scroll up because my thingy's not liking it. Why else? Yes, well done, guys. Really good. So carbon dioxide is dissolved in the ocean. So carbon dioxide decreased because plants and algae used carbon dioxide for photosynthesis. and it dissolved. I'm going to try not to write on the exam question. In the newly formed oceans. Oh, I can't write down the bottom. No, otherwise that happens. Go back. Sorry, that's me trying to write on the bottom, which can't do. In the newly formed oceans. Okie dokie. Why then? So moving up to water vapor. Why has water vapor decreased? Water vapor in the atmosphere decreased? Yeah, guys, you've actually gone into a bit more detail than I have about carbon dioxide. If you can add that in, that is great. I've slightly not got enough space, but if you can then say that plants, not plants, small creatures then use the carbon dioxide for shells, which decrease the carbon dioxide in the water, so more could then dissolve in the ocean. That is amazing. That's really good knowledge, really good. Yeah, lovely. Well done. I like the phrase you've used there as well, guys. Cooled and condensed. Good use of word condensed. It's cooled. So water vapor decreased because it cooled as the earth cooled. And condensed to form the oceans. Really good. And we've also then kind of answered this bit as well, or spoken about this bit about where the oceans have come from. So we've kind of killed two birds with one stone there, which is great. What grade is this question? It's well, it depends. If you get 1 to 2 marks out of it, then it's only going to be it's not going to be worth a huge amount to you. But if you manage to get 6 out of 6, then it's going to be worth a lot more to you. So I guess it depends how well you do in the question as to what grade. There's no, with these big questions, there's no kind of, it's not aimed at higher or foundation. It's aimed at whatever level you can do. So you have to try and have a go at getting as many marks as you can in these kind of questions. Cool, no worries. Good. So there's lots of other things we could talk about. So as well, we could talk about how the volcano, why the volcanoes have decreased. But the final thing that we haven't spoken about yet is the nitrogen. This for me is the hardest thing hardest thing to work out. Why is the amount of nitrogen increased in the atmosphere, do we think? Or do you know? Anybody know? Yeah, really nice. Good. So there's two things you could have spoken about. You could say that it's to do with our nitrogen forming from we used to have ammonia, which is another gas, ammonia gas. We used to have ammonia in the Earth's early atmosphere, which hasn't been mentioned on here, but you might already know that. And it has then reacted to form nitrogen because it reacted with oxygen. Or, I think as some of you have said as well, nitrogen gas has come from bacteria have released nitrogen gas from the soil. And that probably came from volcanoes, but nitrogen gas doesn't come specifically from the volcanoes. So I wouldn't necessarily, there might be some nitrogen gas from volcanoes, but that wouldn't be the main contributor, the main reason. So what we're going to put, nitrogen increased because bacteria released nitrogen from, I'll put nitrogen containing compounds in the soil. So that to me is probably the hardest one. So in order to get the full 6 marks, 5 to 6 marks, you have to have talked about carbon dioxide, water, nitrogen, and oxygen. Okay, you have to have talked about all of them. And then the more detail you go into, the higher chances that you'll get 6 marks. If you haven't made any mistakes, then you'll get 6 marks. But if there's a slight inaccuracy, or you've made a mistake, or you've missed something, then you can't get 5 to 6 marks. So there are also other things you could have said. I haven't said everything here. You can talk about rock formations and carbon dioxide being trapped in rocks. You can talk about volcanoes. I think we said we can talk about volcanoes because as the Earth cooled, the volcanoes became more of a crust and less of an active volcano. So you can talk about that as well. But if you can talk properly, like solidly, about our carbon dioxide, water vapor, nitrogen, and oxygen, then you should, and there are no mistakes, you should be able to get yourself 5 or 6 marks. Okay. Anybody got any other other thing they wanted to add, or a question about this? Otherwise, we should think about moving on, I think. But please, if you've got questions, please ask, because this is what we're here for. And as some of you have probably noticed, if you say something and I don't respond, it might be that it's just disappeared on my chat and I can't see it again. So please feel free to say it again, because I only get a little bit of chat on my screen, so I might have missed it. So please say things again. Yes, you could say that as well, Evan. Yeah, but, we might want to say where it's come from, though, is the only thing. So that's not necessarily saying where it's come from. Could you mention deforestation? It's a good thing to remember, actually, deforestation. But in this case, because we're going from the early Earth to the Earth today, I wouldn't necessarily mention deforestation, because this is going from volcanoes, no life, no water on the planet, to lots of water on the planet, only a few volcanoes, etc. We're looking at the big change between the really early Earth and Earth today, rather than the small change between Earth maybe 250 years ago to now. So that's a really good thing to think about when we're talking about the climate change, recent climate change, or recent changes to the Earth, but not in this question, if that makes sense. Could you say that CO2 decreases, volcanoes become crushed and release less of it? I know what you're trying to say. Think about the phrasing, though. It's asked us to explain how the amount of carbon dioxide has decreased. So the carbon dioxide in the atmosphere won't have decreased because volcanoes were releasing less of it. It just won't have increased. So you are correct in what you're saying. It's just not answering the question. Okay, so you need to be saying why it has decreased rather than why there's not more of it. I hope you can see the difference between them. So volcanoes no longer releasing CO2 will stop contributing to the amount of carbon dioxide that's in the atmosphere, but it's not going to have decreased the amount that's in the atmosphere. And that will come from it dissolving in the oceans and plants and algae using it for photosynthesis. That's taking it out of the atmosphere. Okay, good. Lovely. Yeah, this is all exam boards. Well done. Yeah, good. Thank you. Perfect. Nice, guys. Okay, let's move on to the next question then. Now, this question is mainly higher content because we are looking at reacting masses. Now, you have to be able to talk about the ratios of reacting masses at foundation, definitely. This question is presented in a way that I think could be found in a foundation paper. It'd be probably towards the end of the foundation paper because it's a little bit harder, but I think everyone should have an understanding of what it is, or needs to have an understanding of what it is. So it's hard though. I know, moles, yeah, but we don't have to think about it in terms of moles. We can just think about it in terms of ratios. So titanium is extracted, where's titanium? There it is, from titanium dioxide. Oops, I've just scribbled over the 2. In a 2-step industrial process. In step 2, 40 kilograms of titanium 4, so 40 kilograms of titanium 4 is added to 20 kilograms of sodium. The equation for the reaction is given here. Oh, I might as well write it on here actually. 40 kilograms and 20 kilograms. The relative atomic masses have been given for us of sodium, chlorine, and titanium. Explain why titanium chloride, so this is our, well, I'll ask you guys, explain why titanium chloride is a limiting reactant. What's the formula for titanium chloride? They haven't told us, but they've given a few different formulas. Which one is the formula for titanium chloride? What do you guys think? What's the chemical formula of titanium chloride? Good, well done. Yeah, well done, guys. Good. TiCl4, titanium, Ti, chloride means it's just chlorine, no other elements. So it's titanium and chlorine, nothing else. So that is our titanium chloride. Explain why titanium chloride is the limiting reactant. So if we're talking about limiting reactants, what is the limiting reactant? What does that mean? Can anyone explain it to me? You don't have to have a definition, but it's good to understand what it means. What does it mean? And it's absolutely fine for you not to know. That is also totally fine. Nice. Okay. I like these definitions. Yeah, good. Really good. So fewer moles when it gets used up first, because it's got fewer moles, it's the one with the fewest number of moles. Good. It limits the products formed. Yep, you're exactly right. Exactly right. So we're looking for one of them. We've only got two reagents or reactants, sorry. Titanium chloride and sodium. So we're going to look and see which one has the fewest reacting moles. And now I made a point of stressing reacting there because I can tell we're going to need to make sure that we're not making a common mistake when we do this. So I think some people have already said it. Oh, I like that actually. Reactant not in excess. I'm going to put that down. Fewest reacting moles. Yeah, that's a C, reacting moles. Good. So what's the equation then for working out the number of moles of a reactant or of something? I think somebody's already said it, but what is the equation and how do you remember it? Moles equals what? Good. Really nice, guys. And you have to commit this to memory. You need to memorize this. So moles, which we measure in mole, that's our unit, mole, equals the mass of something, usually in grams, divided by the MR, or relative atomic mass, or relative molecular mass, which is grams per mole. And I was just about to say that. I remember Mr. Moles as well. Okay, so we can think about it. If I put it into a triangle, if you can remember mass equals Mr. Moles, mass equals Mr. Moles, then we can put it into an equation triangle. Or if you're not a fan of equation triangles, which is absolutely fine, you can just rearrange the equation. So we divide by the MR, we divide the mass by the MR to get moles on its own. But if I was going to write it in an equation triangle, it would look like that. With, and let's just change my colors, mass times moles there, and then dividing by over there. If you haven't seen these before, I'm not going to go through specifically how to do those because I'm aware that we don't have a huge amount of time, but that could be something that you request for a future drop-in perhaps, how to use equation triangles and all that, and rearranging and stuff. So good, that's how we can remember it. Okay, so if we're looking at how do we know it's a moles question, good question. At the moment, all I'm focusing on is the fact it's talked about the limiting reactant. And because if I'm looking for what's the limiting reactant, then I'm looking for the reactant that's not in excess or the one with the fewest reacting moles. So I need to now work out how many moles I've got of titanium chloride and my moles of sodium. So when I saw this term limiting reactant, I immediately thought, right, I need to know how many moles there are of everything. And so in order to do that, I need to use my equation, moles equals mass over MR. Now, first spanner they've thrown in the works then. They've given us 40 kilograms of titanium chloride and 20 kilograms of sodium. So what do I need to do in order to be able to use these numbers in my equations? Good, welcome, well done. We will, Thalia, good. You've noticed it, which is awesome. You've noticed the sneaky, but we'll come to that in a second, yeah. To begin with, though, I just want to know how many moles we've got. So how do I do this, guys? 40 kilograms. I can't use kilograms when I'm doing this equation. I can't. I have to use grams. Good. So we have to work out how many grams there are. So if we're going from grams to kilograms, how in 1 kilogram there are how many grams? In 1 kilogram there are how many grams? Yeah, good. 1,000 grams. So if there's 1,000 grams, to get from grams, we're going, sorry, from kilograms to grams, we have to times by 1,000. So if we go from kilograms to grams, we have to times by 1,000. So that means we've got, where can I write it? Let's write it somewhere else. So our mass of titanium chloride is 40 times 1,000. So 40,000 grams. I can't see what I've written because my pen's being slow. Oops, that's kilograms. And then our mass of sodium is 20 times 1,000, 20 kilograms times 1,000, which is 20,000. Again, I can't see what I've written because it's being really slow. Oh dear. Oh no. Oh. It's having a funny. Sorry about that, guys. I think it thought I pressed a button or something. Oh no, I've done something and now it's not responding to me. We'll try that again. Come back. There we go. Where did I get to? So 20,000 grams. So 20,000 grams of sodium. So I can go back to my equations now and work out the number of moles because I've got the correct number of grams. So really well done if you've done it. You do need to convert it to grams, definitely, because these numbers here, our relative atomic masses, are in grams per mole. So it has to be in grams in order for us to be able to use these numbers. Yeah, exactly. Well done. We have to use grams per mole. So we've got our mass in grams divided by our relative atomic mass rather than our relative molecular mass, because we're talking about, oh no, in the other one we're talking about atoms. We do need to work out our MR though of titanium chloride. What is the MR of titanium chloride? Oh, where am I going to write this? What's the MR of titanium chloride and how do we work it out? Yeah, technical difficulties, yeah. I'm good at having technical difficulties. I'm going to go to another color because I'm working this MR out and I haven't given myself any space. The MR of titanium chloride is what? Nice, well done. How did you do that then, Evan? How did you do 190? We've got to do titanium, which is 48, plus 4 lots of whatever chlorine is, 35.5, which should be 190. So our MR of titanium chloride is 190. I'm going to try and keep my color coding the same if I can. So we've got, for the moles of titanium chloride, we've had to do a lot of working out to get here. So we will have already, well, once we work this out, we will have earned ourselves some marks at least. So our mass of titanium chloride was 40, oops, wrong color. I'll just write that one in instead. 40,000 grams divided by 190 grams per mole. And if you can do the maths for me, that would be awesome. And our moles of sodium, again, we've got to do mass in grams divided by the AR this time because it's only one atom. So in this case, it will be divided by sodium, which is 23. And again, if you can do the maths for me, that would be awesome. Grams per mole, that is. What have we got? Really good. Nice. Good. Yeah. So, has anybody managed to do the maths for me? If we do 40,000 divided by 190, we should get 211 moles. And if well done, Tamara, that's brilliant. And then if we do 20,000 divided by 23, we should get 870 moles, I think. So we haven't finished yet. We are still working our way through this, and we might have to, well, we'll see how far we get through the next question. But how do we do this next bit? I've got now, again, I'm going to swap colors. We'll go to purple this time. I've got 211 moles of titanium chloride, and I've got 870 moles of sodium. So there's quite a big difference. But do I know for certain how much titanium do I need compared to sodium, or how much sodium do I need compared to titanium? Good, really good. Now, some people find this really hard to work out, but we have to recognize that, and I'll just rub these scribbles out over here. Oh, apart from it's not doing anything. Oh, it might be because I've put it back on. Apologies. We're going to have to use these scribbles as they are. If we look at this reacting ratio, and I can use the one below, but I've scribbled all over it already. We've got 1 titanium chloride to every 4 sodiums. So that's the same with moles. I need 1 titanium chloride to every 4 lots of sodium. So just to work out how much sodium I would need, if I do 211 moles times by 4, this is how much sodium I would need. So 211 times by 4 is 844 moles of sodium needed to react in a 1:4 ratio. And I've got more than 844 moles. I've actually got 870 moles of sodium. So I can say that, oh, I can't write down the bottom again. Hence, sodium is in excess because 870 is bigger than 844. We only need 844 moles to react with our titanium. So the sodium is in excess. So our titanium, just to make sure we've answered the question, because the question's asked, which is the limiting reagent or reactant? I keep saying reagent, apologies, that's A level. Which is the limiting reactant? I said it again. So our titanium chloride is the limiting reactant, and we have to say that in order to get that final mark. So titanium chloride is the limiting reactant. And just so that we have checked where we're going to get all our marks from, it's a lot of working for 5 marks. I know what you mean. Yes, I totally agree. It is. So we get 1 mark for working out the moles of titanium chloride, 1 mark for working out the moles of sodium. So they're a bit stingy on their mole marks here, because actually we've already done some conversions and some workings out. So they are a bit stingy, but that's fine, because we then get a mark for doing the molar ratio. And then 1, 2, 3, we get a mark for actually doing the calculation. And then finally for saying that titanium chloride is the limiting reactant. So that's our 5 marks there. It's a lot of working, you're right, for 5 marks. but it's all very useful skills, especially if you're interested in going into chemistry or biochemistry, anything medicinal, anything like that. You need to be able to look at and be happy with your reacting ratios. So it's a very good question for testing your knowledge. Can I repeat the way of thinking for the last part? Yes, I'll do that in 2 seconds time. Do we do key stage 3? No, we don't, I'm afraid. So ratio bit, let's explain the ratio bit again. So think about it in terms of cake. If you've got in your cake, if you're baking a cake, you have to have 1 block of butter for every 4 eggs. So if I'm counting the number of butters and eggs you've got, if I have 3 blocks of butter and 10 eggs, I have to have a ratio of 1 to 4 for my blocks of butter to my eggs. I have to have a ratio of 1 to 4, so I don't have enough eggs to use 4 packs of butter if I've only got 10 eggs. I need 12 eggs, 3 packs of butter. So if I need 12 eggs to use 3 packs of butter if I'm using it in a 1 to 4 ratio. So we're doing the same thing here. I have to have 1 lot of titanium chloride to 4 lots of sodium for them to react. So if I don't have a 1 to 4 ratio, then they can't react fully. One of them is going to be stopping the other one from reacting fully. And that one, the one that's limited, the one that's got the fewer moles in that reacting ratio, is the limiting reactant. So in this case, we've got 870 moles of sodium, but 211 moles of titanium. So we might immediately say, oh, well, there's fewer moles of titanium, so that has to be the limiting reagent. And you'd be correct, it is, but you're not going to get all the marks because we have to prove why it's a limiting reagent and it's the reactant. And it's a limiting reactant because if we work out how many moles of sodium we need to react with all of that titanium, we have to have 4 times as much sodium. And 4 times as much sodium is 844 moles. And we have got more than 44 moles. So we've got more than enough sodium to use up all of our titanium. So the titanium is therefore the limiting reactant. Okay? Let me know if anybody's not happy with that, but let's try and see if we can just do this and the first bit of this next question, and then I'm going to need to go on to doing showing you the website and everything. Good. Okay. So let's see how far we get into this question. So electrolysis, quite another very hard topic in chemistry. Again, this is something that everybody has to know, but writing a balanced ionic equation, I think, would be probably higher rather than foundation. But as a foundation student, you do have to balance ionic equations, but you might not necessarily have to write them from scratch, I don't believe. Maybe at the end of the paper, but maybe not. So let's have a go, though, because we're definitely going to have a go at it. Chlorine is made by the electrolysis of concentrated sodium chloride solution. Sodium chloride solution contains sodium ions, OH minus ions, or hydroxide ions we could say, chloride ions, and hydrogen ions. At the positive electrode, chloride ions lose electrons to make chlorine gas. Write the balanced ionic equation for this reaction. So they've told us what the equation is already in the question. They've said chloride ions lose electrons to make chlorine gas. So which one of these ions that they've told us about is a chloride ion? Which one of those is a chloride ion? I've been told that I'm making chlorine gas. So I know that my chlorine gas has got to go in my products because I'm making chlorine gas, so it's a product. So I'm going to put my chlorine in already, chlorine gas. But what's a chloride ion? Good. Okay, no worries. Thank you. Have a lovely day. See you later. This is a half equation. Yes, good spot. It is a half equation. But we can also call it an ionic equation because we're talking about the exchange or the interaction between the ions in the solution. But you're right, it's also a half equation, so really good. Good. Okay, so Cl minus, well done for spotting. Cl minus is our chloride ion, and it loses electrons. So we've got our chloride ion. It's negatively charged because it's got an extra electron. It's got an extra negative charge that makes it negatively charged overall. Instead of having an equal number of protons and electrons in the chloride ion, in the chlorine atom, it's gained an electron to make it negatively charged. A little negatively charged electron, it's gained it to make it negatively charged. But at the electrode, it loses that electron to become neutral again, and then we've got a spare electron just hanging around. So I'm going to move this up a little bit actually. At the electrode, we lose the electron, and it says use E minus to represent an electron, so that's what I've done. So I personally prefer to write plus an electron. So we started with a chloride ion, it lost an electron, so then I've got an electron there. You can, if you want, where am I going to write it over here? You can write Cl minus minus an electron, makes Cl2, but we will do some balancing in a second. You can put the minus in, but I think that can confuse things when you come to looking at balancing charges and making sure that everything is sorted. So you can do that, but just be wary of it. You would get the mark in this case, but just be aware of it. Now, lots of you have noticed that we need to balance it properly. So we need to have the same number of chlorines. In the left-hand side of the equation, we've only got one chlorine, and on the right-hand side, we've got two. So we need to balance it somehow. So there's one of two ways we can do. We can do Cl2 because they've told us it's Cl2, and I think somebody said it earlier, chlorine is one of quite a few diatomic gases. It's a diatomic gas or molecule. And because it's diatomic, it has to travel around in a pair. You can't ever have a Cl on its own. It either has to be a Cl minus, it either has to be an ion, or it has to be in a pair. Okay, so it has to be Cl2. So we can either, halogens, loads of the halogens are all diatomic. In fact, all of them are diatomic. And then oxygen, nitrogen, they're both diatomic as well. Good. Good. So you can either write a half Cl2, because then you've only got one chlorine, or you could double everything. So on this one, I'm going to actually just do it in another color. On my other one, I will write the other version. So you can either write half Cl2, because half of Cl2 is just Cl, so that's fine. And then that makes that balanced. Or you can write two chlorines, but then we have to give up two electrons, because both chlorines give up an electron to produce Cl2. So one of the two, it doesn't matter which one you do, but one of the two will give you the chlorine. Give you a correct balanced equation for this chlorine. Really nice. Well done, those of you that have done it. Yes, Tamana, so you're right. If you have two chlorines, then they lose two electrons. That's correct. But if you're only having one chlorine, then it's only going to lose one electron to become neutral. Okay. How are we doing for time? We've got 5 minutes. Okay, so I might look, because I know how slow my computer is going to be, rather than moving on to the next bit of the question. What we're going to do, I think, is finish the lesson there, and I'm just going to show you the website. So, you had a question. This is slightly off topic. When it comes to the subatomic particles of an atom, like protons and neutrons, are there smaller particles inside them that give protons and neutrons their mass? This is physics, A-level physics, but they're technically, you can then break down a proton or a neutron into a smaller particle, yeah, but we don't have to do that at GCSE, because that's way further in A-level physics when you start talking about breaking them down even further and stuff. It does get really interesting, but we definitely don't need to go anywhere near that at GCSE. Yeah, exactly. It's awesome. It's really awesome. Great questions though. Okay, so let's have a look then. You just have to bear with me whilst I get this up on my screen and I stop sharing this and start sharing something else. So what? Oh, I need to share the code with you, which I haven't done. Let me, whoops, share my screen. So, you guys, so if you're interested in tutoring, I'm about to show you the website in a second, but we have all this GCSE tutoring available on the website starting next week. So we're on YouTube for the end of this week, but then it's on the website. And if you're interested, you can add, you can use the code tutor14 to get 2 weeks free trial. So please go and have a go, have a look and claim your 2 week free trial using the tutor14 code. Even if you aren't sure if it's something that you're interested in, it's a good opportunity for you to have a go and trial it for 2 weeks. So that's tutor14, and I'm going to show you now if I can get, again, I'm concerned my laptop is going to freeze on me. Whoops. But we will try to get the SnapRevise website up so I can show it to you. I know, guys, honestly, we would love to be able to do it for free, but somebody's got to pay some wages. It's not, you know, we can't get everything for free, I'm afraid. So we try and do as much as we can, and especially at A level as well, we do offer free classes once a week on a Sunday. So you know, we do try, and we've done 5 weeks of these, so we've been trying to give you as much as we can, but we have to move on to the website now. So if you're interested, please go onto our website and have a look at the free trial. Oops, I've gone to the wrong bit. If you go on, and just checking the time, I need to log off in a second, and my internet, oops, it's being nice and slow. If you go onto the website, at the top, you should see, if you go onto the homepage, you should see a little tutoring button. If you click on the tutoring button, you can scroll down and find your course. So we offer A-levels and GCSEs, sciences and maths. So find the one that you're interested in, click on that one. So in our case, if it were working, I would be clicking on GCSE chemistry. It's decided it doesn't want to work for me today, so that's fine. Click on GCSE chemistry, and then you can see the schedule, and the schedule has got all of the classes for the rest of the academic year on it, so you can work out what you want to go to, and it shows you what's going to be in the classes and when the drop-ins are and all of that information. So that's all on the website. There's a link for you on the chat now, so you can go on it yourself. And yeah, as we say, because we get 3+ sessions each week, they actually work out to be about £3 a session, which is obviously a lot cheaper than a personal tutor would be. So yeah, okay. So have a lovely evening. If you're coming to the classes on Sunday, then I might see you on Sunday. Otherwise, have a great week, and maybe hopefully see you on SnapRevise, even if it's just for your free trial. And don't forget, you can use that code tutor14. Okay, I have to sign off now because somebody else needs to log on. So have a lovely rest of the week, and I will see you soon. Thank you very much for coming. Well done, guys. Thank you very much. See you later. See you Sunday. Bye.